why the randomness is so cool. Hi folks, before I guide you through how to run code to generate true randomness, true quantum randomness from your machine, let's talk about randomness. Let's see, what is it? I generally prefer to think of randomness in three categories: pseudorandomness, classical randomness, and quantum randomness. Pseudorandomness is simple. It is computationally generated and appears random, but ultimately it is deterministic. A computer cannot provide random results because computers are inherently deterministic. They follow explicit algorithms or instructions. That means given the same initial condition and the same algorithm, the output will always be the same.
No, your randomness does not confuse me.
To generate a pseudorandom number, we generally use a seed or a small string of bits. To generate a pseudo-random number, we generally use a seed or a string of bits. The current time in milliseconds can serve as seed, and then that seed is transformed into a much larger pseudo-random number.
Impressive. But what does it even matter if I'm random or planned?
Next, classical randomness is already more interesting. It relies on the physics of chaotic or very complex processes. In systems like atmospheric noise or chaotic systems like three-body problem or lava lamps, the initial parameters or any little change will alter the final state of the system dramatically, and that will result in a different random number. This classical randomness is the result of complexity. The greater the entropy, the more random randomness. Pseudo-randomness, I calculated it would take you about 3 trillion years on the modern supercomputer to reverse engineer the random number from 128-bit seed. With classical randomness, who knows how long? There's not even an algorithm that we know to predict or decode chaotic systems, but in principle, we could do that. Because classical mechanics is considered to be deterministic. It's just we don't have an infinite compute and perfect knowledge of every little parameters. Now, quantum randomness, that's a new level of crazy. The crazy I like. Unlike pseudo-randomness or classical randomness, quantum randomness arises from fundamental unpredictability of the universe, not from our lack of knowledge or computational power. Well, you might argue. The early quantum random number generators mainly exploited the phenomenon of radioactivity. It's impossible to predict when atom will decay. You can give me a half-life of an element, but the decay of the individual atom within time frame t can only be described probabilistically. But radioactivity can mess up detectors and hardware and all of the equipment. So now many of the quantum random number generators exploit the qubit in a state of superposition. Qubit collapsing generates a random binary outcome, 0 or 1, and that's what we're going to explore today. We're going to put 5 qubits in a superposition using IBM quantum computer, and we're going to collapse them. You can use Google Colab, which basically is free and you don't need to set up local Python environment. Qiskit is just a SDK or software development toolkit that allows you to program quantum computers specifically for IBM. Install the dependencies for Qiskit and then you import the dependencies for Qiskit. For the next step, you actually might have to create an IBM account, get your API key, the token, authenticate. We're going to select the backend. What it means is IBM has quite a few quantum computers with different number of qubits on them. Here, I'm only defining circuit with 5 qubits. All of the computers use logic gates. They are the simplest form of algorithm. They take input and make one basic logical decision, like reversing yes to a no, which is NOT gate, or checking if both inputs are yes, then the output is yes. This is an AND gate. By combining multiple logic gates, we create a circuit. So in classical computer, we only have X or NOT and the variations of those gates. In quantum computing, there are way more gates. Quantum circuits can be built based on quantum gates. In this example, we're only using Hadamard gates. All the qubits are going to be initiated in the state 0, and I'm gonna take each qubit and place it in the superposition of 50-50. We're gonna use a Hadamard gate. And as an outcome, after measurement, 5 classical bits to store measurement results. Actually, if you go to your IBM account, log in, you can see IBM Q had 126 quantum bits. That's a lot. It's a lot of quantum bits, which means actually we could have submitted a way larger quantum number. Let me try that again. Completed. Pending for 45 minutes. Only run for 4 seconds. Got it. 1063382. Alright, now that we generated a random number, whatever yours is gonna be, let's think about it. You might say, Alena, but what if quantum mechanics is only random because of our interpretation of the world? What if it's a limitation of our knowledge, not that the universe is intrinsically random? We cannot predict it because quantum mechanics is incomplete. Maybe. But it also depends on your interpretation of quantum mechanics. There are deterministic interpretations like many worlds theory. Even in multiple worlds interpretation, where all possibilities that could happen, you, observers, still find yourself in one random world. And if the conscious mind can only experience one outcome, then for all practical purposes, it is random to us. The real question is, why do I experience one outcome? And it's very deeply philosophical, and it raises the question of what I and experience is. But I thought another way to put this question, why don't I experience the whole wave function? That would be deterministic, because Schrödinger equation evolves deterministically. But what if I could experience the whole wave function? I would be a photon. Right, but why can't we? Well, most of the scientists say that your world is tied to a classical outcome because your sensory organs operate in the macroscopic world. They're part of the environment that causes decoherence. And at these scales, phenomena like entanglement and superposition are practically non-existent. Another crazy idea is that quantum randomness play a role in the establishing directionality of time, or what's called error of time. But I'll talk about that in my next video. The corals are slowly going to sleep, so their UV light goes down. Thanks for watching!